Hi, I'm Scott and welcome back to Canard Boulevard. This video we're going to do things just a little bit differently. Up until now my maintenance videos have been basically whatever I happen to be doing that day that I spent in the hangar. And as a result it's kind of been scattershot where I might have done a little bit of electrical, a little bit of heating, a little bit of this, a little bit of that. And unless you are watching every video in sequence, there's really no progression and no payoff at the end. And I recognize that because I wanted to go back and see when did I do this in that video, and I couldn't even remember which video it was in, then I had to like go through. Okay, so we're gonna do things differently in this video. Instead of this video being, hey, here's the day I spent at the hangar and here's what I worked on, this video is going to consist of several weeks of work, and it's all going to be in one category, and that category is electrical. So this is going to be the electrical work video, and then I've got the heating video and the nose gear video and that sort of thing coming up, and I'll put all the content I've shot for that one system into a single video. That way you can see the progression from beginning to end, and I guess there's more of a payoff and resolution at the end of it. Okay, so let's get on with the electrical video. All right, to start with, I'm going to show you something I've already shown before, which is the relay board, and I'll show you how I designed that. And if you've seen this before, feel free to skip ahead to the next chapter, but just to give some information as to, and some background and context as to how we got where we are, here's my relay board. So I took some time tonight to finish building my relay board. This started out as a circuit diagram that I built here. It's basically a relay interface board for 4 different functions: pitch trim, roll trim, landing brake, and landing light. Because the controls for that are small switches on my side stick that can't handle the large current required for motor actuators and landing lights. So those switches will actuate these relays, which in turn will actuate the items. The relay board that's in there, the circuit design it was designed from originally was defective. It was faulty, and it had, even though it had relays in there, it had the full current of the actuators going through the side sticks, and as a result I burned out one of the coolie hat switches from my trim. So I redesigned the circuit here, and I also added a few extra little features. I added a Copilot isolation switch so that I can turn off the Copilot stick controls, so that if I have a non-pilot over there and I want to let them fly it for a bit, then I know they're not going to be accidentally putting a landing brake down or transmitting on the radio or what have you. So this is the circuit here. So I designed the circuit first, and then I designed the layout of the relays and the sockets. These are socketed relays, as you can see. So if the relay fails, you can just pop in a new one. They're in there quite tight. And then I designed the terminal strip connections. This is the Copilot isolation, which is basically made out of this. I haven't done that yet. I need to solder up a bunch of diodes. So this is the relay board here. And so what I have is a ground. I'm going to put the ground right on there. And then I have 3 inputs. This is the landing light power, this is the landing brake power, and this is the pitch trim. So each of these are going to go to their respective breakers that feed in power to where it's going to need to go. So I will turn on the power there. So the way this works is when the individual switches on the side stick are pressed, it connects a wire to ground. And that's how the side stick works. So this is my ground here. I'll just connect this wire in here. So right now I've got this connected onto the landing light power. So if I ground out the landing light switch, you can see the little LED indicator comes on there, and that will then send power out this connector right here that goes to the landing light. If we go onto the landing brake power, which is this connection right here, and now I have landing brake up and landing brake down switches, which are these 2 here. You can see those 2 are lighting up, and that works a little bit differently. The landing brake actuator actually connects right here, and normally there is no voltage there at all. So if I hook up my meter here, so you can see that. So if I connect it up to my landing brake actuator, you can see there's nothing there. Both leads are grounded. If I select landing brake up, you can see I've got 13.8 volts, and if I select landing brake down, I have negative 13. So it drives the actuator in the opposite direction. And that's also exactly how the pitch and roll trim works. So the pitch and roll trim both work off this breaker here. So here is my roll right, roll left, pitch up, pitch down, and those actuators connect here for pitch and here for roll. So that's it. That's my relay board. It's finished and ready to be installed into the airplane. That's going to be a lot more work because I do have to trace and label all the wires that are going to hook up to this terminal strip here. And that is a job for another day. I still do have to wire up the relays for my Copilot isolation switch, again, for another day. All right, so that's the part where I'd actually already posted that. Now we'll move forward on new stuff you haven't seen. Let's get to work on electrical. Next, I got down to the task of identifying all of the wires coming into this wiring board. Now, what you're seeing here is representing probably 2.5 hours of work. None of these wires, well, actually, there was probably 4 or 5 of these wires that were actually labeled and tagged. And so I could deduce what some of them were just by how they were connected to the relay, but a lot of them I just had to tone out, hook them up, work the various switches, see what actually actuated, what got grounded to what. And as I did each of these wires, I would tag them. And these are temporary tags. I'll put some permanent tags on these once I'm completed, but there was just so many of these wires, and I have to know all these different wires and what they do in order to hook up to my new relay board. Well, that was a great idea. I got my new portable wireless label printer that I got off Amazon, and I'm using it along with my phone to print all these pretty labels so that I can tag every single one of these things with exactly their purpose. Now I'm removing this button that actually has no purpose, and I'm replacing it with a new breaker that is going to be for the trim. And that is to allow me to pull that breaker should I have runaway trim, and also because I want a separate breaker for the trim rather than having it just piggybacking on whatever circuit it was on before. I don't even know what circuit it was using. So now that I have that, I have a separate circuit just for trim. Hey, we're back, and it's a disaster. That brand new label printer that I got off Amazon, that was so great for printing quickly off my phone. Well, the labels have a slight problem in that they don't stick to anything, including themselves. So all those labels I put on, I spent hours putting on the day before, were falling off, and I was in danger of losing the wire identification that had taken me so long to do. So I got my old Brother P-Touch, and I printed new labels because I know that thing works. So another few hours wasted relabeling all the wires and tidying them up. And now I've got to put extensions on all the wires that used to plug in and connect to the old relay board at the top. Now they're going to connect at the bottom, so I just needed to add some extensions on there to accommodate that. Sat down for about half an hour and just printed out labels nonstop into that little bin there with my Brother P-Touch. And now that I have all the labels on all the wires and they're not going to come off, now it's time to bundle things up, clean things up, and install the new relay board. I do have to drill holes to make it fit the mounting points, so I've got to mark those and then drill them. And now that I've got it right, there was a little spot where I had to file to get the screw to fit. Okay, it's in there. Now we start hooking everything up. I have the plan that I originally drew that shows what connects to what. I'm just following that to make sure that I hook everything up correctly. And it shouldn't take too long. Now that I have all these wires labeled, I just pick each wire, find it on the chart, decide where it's going to plug in, and then connect it. Some of them, like grounds, there's several different connections going onto there, but most of these are just one for one, with the exception of input controls, because obviously trim controls for both the Copilot and the Pilot have to go into the same place. There's 2 sets of controls and switches that
that work that way.
Now we try turning it on and see if any smoke comes out. I have not, I've only put these actuator connectors on loosely because I don't know which polarity each of them goes. So I'll have to just test that to see. And if I do nose back and the elevators go the opposite direction, then I'll know how to change that. So let's see. Well, we know the landing light works because I just saw it turn on, and I can see that relay turning on and off, and I see the lights turning on and off. That's a good sign. All right, let's try trim. And that's good. Working correctly. Roll trim. And that one's backwards. Okay, so we need to fix the roll trim. And let's try the landing brake. Brake down. Brake up. Okay, so 2 out of 3, not bad. So now I just got to swap the roll trim actuator connectors, and then we'll be good.
I was actually pretty surprised at how well this has gone together, and that I got everything working the first try. Yay me!
Okay, we do have a problem in that it's saying the brake is and landing light. Oh, the landing light is backwards. I have to switch that in the configuration. It does say the speed brake is down, and when I lower it, it's not recognizing that. So that's an issue I'll have to have a look at. So none of the Copilot controls work, which is as expected because this is the isolating circuit and it is disconnected. So I'm going to temporarily connect that to ground, which tells me, yep, okay, that's working. That's working. Pitch down, transmit. And the brake is definitely working as well, so that's excellent. So the Copilot isolation circuit working perfectly. The only thing that's not functioning is the landing brake switch. The up limit switch is not reading in the EIS. I do need to change the landing light from a positive trigger to a negative trigger in the G3X. But that said, this has been a lot of work, and it's working perfectly. Well, apart from that, that's actually not part of the board. That's just the indicator, but I will get to that. I'm extremely pleased. I do have a new trim breaker that I put in so that I can pull that. If I have a runaway trim, I can pull that breaker and pull it out and kill the trim. I did remove some wiring that was no longer being used, and looks like it's good to go. Three days ago, it was 17 degrees here in Ohio. Then it got up to 60. Yesterday, it was 68 degrees. I spent 5 hours out here working on the wiring. Today, it's 25 degrees and snowing. Welcome to Ohio. It's really windy. I couldn't even open this door properly because I was afraid it was actually going to blow in and hit the airplane. So I'm not exactly sure how much I'm going to get done today. It's really cold. My fingers are already frozen, but I want to try and get the relay board wiring complete. That's my goal for today, so we'll see how it goes.
Well, I did have a problem that I had more things to connect to ground than I had ground available, so I put a little splitter in there so I can split my ground apart.
All right, so this stage of this wiring project is complete. You can see I've got all the relays hooked up here, and if I hit pitch on my control, you can see they actually light up, and roll, same thing there. And then we have the landing brake, which is right here. And then over here we have the landing light. The landing brake normally stays up because that's where it's set to, but if you have it in the neutral position, it's neither up nor down, and neither of those relays go. That's normal operation. If we have a look at the G3X, I've now got it configured correctly. It is showing the volts CAS indicator because the backup battery's turned off. If I turn that on, you'll see that goes away in a second when you can see The number 2 volts comes up there. If I have a look to see what that actually is, you can see that the backup battery is showing at 12.9, so it probably needs a little bit of a charge, but that's okay for now. So if I shut that off, that'll go back down and we get a volts enunciation. If I put the speed brake down, you can see the speed brake enunciator comes up. And if I turn on the landing lights, I get a landing light. Landing light and speed brake, that's all good. So the other one that I'm going to hook up onto there is a canopy. I'm going to put a switch in so that if the canopy is left open, it will enunciate on here as well, which is a good thing to know about. The other thing I do have to do, we're showing 12.8 volts here. I'm going to run a separate EIS line from the battery bus, main bus, into the G3X and configure it to look at that for the voltage. And I may do that right now. We'll see if my fingers will stay unfrozen long enough to actually do that.
All right, everything is connected and working. It's time to screw the panel into place. This really means that it's done and working.
All right, the answer is nope. It's not going to happen today. My hands are frozen. My fine motor skills are not working very well because my fingers are absolutely frozen. There's no way I'm going to be able to work and crimp tiny little DP25 pins in the EIS connector. I'm not going to try it. I'll just end up screwing it up. So I think that's it for today. We'll have to come back and finish this another day. I did get this mounted and screwed in there. If you're wondering what this is, that's a diode pack that is, it's not fastened in yet because I still have to hook up the Copilot isolation switch that will turn off the Copilot switches on the stick over there. And once I've mounted that, I haven't figured out where it's going to go yet. I'm kind of tight on panel space. But once I've mounted that, then I'll have to run a wire from it down to here to hook up to this diode pack, and that will then complete this, and I can box it up and I'll fasten this so it doesn't flop around like it is right now.
Time to install a Copilot isolation switch. I drilled a hole. It's going to mount right between the G3X and the GNS 530, and I put the switch in there after I had soldered wires onto it and tested it out, and guess what? It's not working. The switch was defective, so I had to go back and desolder it, put a new switch on there, and try again. So now I am back here with the second switch, and it looks good. We'll mount it in there. One end of the switch connects to ground. The other end connects to the Copilot switch's ground, so that when you disconnect the ground using that switch, none of the Copilot switches work. Then I go into the back to hook up the voltage to its own input so we get an accurate voltage reading on it, unlike what we have now. So I've installed a Copilot isolation switch here that, when it is turned on, disables the controls on the Copilot side. Right now, it can operate the trim and so on, but if I flip the isolation switch on, all these switches stop working. Now I've hooked up the bus power through a fuse into a different input on the EIS, which should give us a different voltage. So right now we are showing 12.9 volts, and let me measure what we're actually on the bus. So I have 13.25 actually at the back on the bus, and only showing 12.9 here. So we're going to fix that, and the way we're going to do that is by configuring the G3X to read the voltage off a different wire that I just hooked up back there. So I'm going to reboot this into configuration mode and make that change. So currently it's set to EIS power, which is the voltage that powers the EIS module. That's the one that is going through all the different switches and fuses and breakers and so on. So we're going to change that to what I just hooked up, which is main bus volts on pin 25, and we should see it come up there, 13. So we've got 0.2 volts. So that was a 0.2 volt drop that we saw simply from going through the various switches. So that will definitely help. And that is within 0.1 volts of what I'm actually measuring at the battery. So that's much better. So I'm happy with that. So we'll save that. All right, so right here you can see our main bus is at 13.1.
What I actually measured was 13.2, so I'm very happy with that. That's good. If I bring on the EIS backup battery, we should see it come up. So there's 12.9 on the backup battery. I'll switch that off. That's fine. All right, that's exactly what I wanted to see.
So I got a notice from Garmin that the GSA-28 Autopilot servos that I have in my airplane are subject to a recall. There's a service bulletin out for them, and they provided me with a set of free replacements. Free is always good, so there I've got the new one, and then I've got to install all the bracketry that I just took out or took off of the old one that I just removed, and that is my roll servo that I'm working, and that's where it was installed back there. So I take all the control rods and the supporting bracketry, and I have to transfer that across onto that new servo and make sure all the locking pins. And I did put in some torque seal on there just so I can identify if that ever does come loose on that Heim joint rod. So once I have that all together, we're going to install it back into the airplane. And that does take a little bit of effort, but it's not in the easiest place to get to.
Turning left. Turning right.
Okay, you thought the one in the back was hard to get to? That's nothing. This one really, you really want to take the Canard off to get to it, but I really didn't want to do that just to get to the servo, so I'm working at it through this access hatch here. And I had to use a mirror, an inspection mirror to do it, and then of course you have to do everything backwards, which kind of bends your mind, and you kind of have to remember which way you're turning things. I did manage to get, you can see me using the mirror in there and a flashlight. There's my mirror. So it is tough work to do, but I did get it out of there and start the replacement.
Okay, the elevator pitch servo is in, so let's give that a try. Autopilot on, and let's say altitude up.
The trim actuator that I installed last year does have the ability to send its current position out. It's never been connected, so I thought, well, let's connect it. That way I can wire it into the Garmin G3X, and it will show me the position of the trim on the screen, which I don't have now. I don't have any way of knowing what the trim is set to, so this will be helpful.
All right, back in configuration mode. I've hooked up the trim sensor into GP2, I think it was. Let me just check to make sure that's correct. GP2, elevator trim. So let's calibrate it. Sorry about the horrendous noise as the helicopter's taken off outside. So now that I've entered that into the G3X and I have calibrated it, I now have my elevator trim showing right here. And as I move it, you will see it reflecting the position of my elevator trim. There's all the way to full nose down to nose up. So it's always had the ability to do that, it just never was hooked up, so now it is. Next I need to hook up the landing gear so that I can get landing gear warnings on here. Well, this has been a long day, it's not over yet. I gotta go home and do some more layups on the landing gear, but day at the hangar is complete, got lots done, got the relay board finished, tucked in, got the Copilot isolation switch installed, tested, working, replaced both the Autopilot servos, and got the trim indicator wired up and working. Also got the bus voltage wired into the EIS, so I have a good voltage showing on the G3X. I think we'll leave this one here for now. I really appreciate all you guys watching these videos and commenting and being so positive and supportive. If you could leave just a quick comment below if you have any questions, comments, suggestions, and of course click like and subscribe to the channel. It really helps me out when you do that. Thanks for watching. All right, off to do more work on the landing gear.